Good afternoon and welcome to this Zyxel webinar about CCTV switches. And today we are going into a bit more technical detail on how the new features actually work. My name is Jukka Vesa. I work as a sales engineer for Zyxel. If there are any questions during the presentations, please put them into the questions section of GoToWebinar and we will cover them at the end. First off, we will start on a bit of a general level on what is surveillance switching and what are the new products that we are introducing and why we have implemented such features. And then at the end, we are going into more detail on how these new features actually work. But let's start. Okay, so what is a surveillance switch? We all know that the surveillance IP camera market has been skyrocketing the last how many years, and switching hasn't really been able to keep up, to be honest. Features that we are looking for in security switches or CCTV switches are functions like the extended range, where we can extend the cable length above that 100-meter limitation that we usually have with Ethernet. Large enough PoE budget, so we can accommodate all the devices actually requiring that PoE power. A wider temperature range, so we can use the switch in colder environments, which is really important for us in the Nordics. Dedicated uplink ports, so we do not have to consume our PoE ports for the uplinks between the switches. Specialized hardware and software, which usually hasn't been on security switching. And of course, the software features going along with these. So first, let's start with understanding PoE, because PoE is the heart of CCTV switches. So what is power over Ethernet? It's a way for us to send power to devices over Ethernet cable, simple as that. So we have a PSE, a power sourcing equipment, or a device sending that power. In this example, it's a switch, but it might as well be a power injector. And then we have a PD, or a powered device that needs that power from the PSE. So it might be an IP camera, it might be a wireless access point, an IP phone, or other, for example, a door access card reader or whatever. There are different standards for PoE. They are in three major groups. There's PoE, PoE Plus, and PoE Plus Plus, or AFAT and BT standards. These standards include many classes, but on the top level, PoE is maximum 15.4 watts, PoE Plus 30 watts, and PoE Plus Plus, or BT, maximum of 60 watts of PoE power. When looking into a bit more detail on these classifications or standards, on some of these standards, like the AF and BT, there are multiple classes. And especially in the BT, it is very important to note that there are classes 5 and 6. So not all BT powered devices consume the full 60 watts of power. And this is very important when we introduce the product portfolio, to understand that not all BT devices consume the whole 60 watts of PoE budget. Okay, so understanding the requirements on PoE. Well, when usually OEM style PoE switches have a fairly low amount of PoE power, PoE budget available, which might be okay for devices that consume quite less of power, like IP phones or wireless access points where there are not many clients around. but especially cameras, and especially cameras with night vision, motorized cameras, heated cameras, they start to consume quite a lot of power. And of course, the PoE features on the switch must be configurable, so you can support all of the standard devices and also the devices that do not support any PoE standards, so non-standard devices. So when you pick the wrong device, it might, or a wrong switch for the job, it might lead to the issue that it cannot apply to the standard or lack of standard that the PD requires. So you can't manually adjust it to the requirements of that powered device. The other issue is, due to these fairly low PoE budgets, that you might have to install many switches for powering all of the devices. And of course, multiple switches, meaning the installation becomes more complicated, meaning that you need to invest in more hardware. Okay, so the ways we can get around this: we support consumption mode and we support classification mode. So classification mode, we give the classified amount of power required, even though the device might not actually use all of that power. So as standard, we use something called consumption mode, which we only reserve the amount of power for the device that it actually consumes, so no more than that. So we can more efficiently make use of our PoE budget. So for example, we have a dome camera, which is an AT standard, and by standard it would consume 30 watts. So if we would install 20 IPTV cameras like this, or IP cameras like this, they would consume 600 watts of power. Or they actually would not, but they would reserve 600 watts of power from the switches. Which would mean even that if you would use our biggest surveillance switch, which has 375 watts of power, or PoE budget, you would need to use 2 of these switches. Okay, but if you use consumption mode, you find out that the camera actually requires 16 watts instead of 30 watts. That's almost half the classified amount of power. So you can actually install 20 cameras to the switch and only reserve the 320 watt amount of PoE budget, which the cameras actually consume. So the real consumption of the device is consumption mode. And once again, you only need 1 switch. You can more efficiently use the PoE budget of the switch. So very nice feature indeed. PoE is widely adopted, so we see more and more PoE powered devices coming to the market. It's not only IP phones or cameras or APs nowadays. We see card readers coming with PoE. We see all sorts of fingerprint sensors, facial recognition devices, people counters that you see in shopping malls, how many people have passed this door in X amount of hours, yada, yada, yada. All sorts of IoT sensors are using PoE nowadays, so it's not just only for cameras. And more coming. So it's really important to have that network backbone up to date so you can accommodate all of these devices. And as previously said, the options available need to be vast, so you can support all of these type of devices. You can obviously set if the port is in PoE mode or not, meaning does it send power or not. You can set a PD priority. So if you have low priority devices, what happens if the switch runs out of PoE budget? Well, I will drop the low ports first, obviously. The power up mode, which is the standard or classification it starts to offer to the device, you can set that as AF or AT. And if the device is not according to PoE classifications or standards, you can set the maximum power manually to the switch. And of course, the extended range, or if you want to negotiate the power via an LLDP. So few words about LLDP. Oh, sorry, extended range, not LLDP. So extended range is our way to, not our way, but a standard way of supporting up to 250 meter cables between the PSE and the PD. And by doing that, we have to limit the transmit speed to 10 megabytes per second and a couple of other things. More details about this feature later, how you set it up, etc. All of these switches have a wider temperature range, so you can install them not in outdoor environments, but in waterproof cabinets that are outdoor but not heated, for example, parking garages or electrical cabinets or whatever. And this doesn't mean that these are outdoor switches as said, so you still need some water protection, etc. But the temperature range is there. The hardware is made very robust, so especially the surge protections has been improved 4 times. The switch, of course, is grounded through the power socket itself, but you also have an additional grounding screw on the back of the device where you can ground the device to, for example, to the device rack or a grounding block of some sort. Then a bit details on the 1300 series, which is our unmanaged CCTV switch series. So improved surge protections, extended range, and dedicated uplinks for the connection between switches. So you do not need to use the PoE ports for the functions. You don't need a PoE. And since these are unmanaged switches, you don't have the software features available. The models that we have available are 1310 HP, 18 HP, and 26 HP. So the PoE budget is ranging from the smallest of 130 watts to the bigger of 250 watts. And all of these unmanaged switches are always in consumption mode. So they only allocate the amount of power to the power device that it actually requires. On the 1350 series, on the other hand, we have added on top of those 3 features talked about earlier, we have the continuous PoE, which keeps the PoE ports up and running, even though there might be a software reboot. And then we have a feature called auto camera recovery, which we will introduce later in very much detail. So that is a way for you to automatically try and recover the cameras and get an alert if something goes wrong. Then the managed switch portfolio. So we have the 6-port, 12, 18, and 26-port versions available. And as these are managed switches, you can manage them via a web interface, and they are basically a standard layer 2 switch. So you have all your virtual LANs, all your spanning trees, all your port protection available that you would have in a normal layer 2 switch, added with these surveillance features that we are talking about today. You can also manage the switches via CLI, so with an SSH or Telnet or console port. And these will come under Nebula Management or cloud managed platform current schedule is mid 2020, so during summer 2020. And you also have a bigger PoE budget available, so up to 375 watts instead of 250 watts. That was in the unmanaged series. And then on the 6HP, we also support the BT standard power, so up to 60 watts. But as described earlier, it's not that all BT standard devices require that 60 watts. So that's why we have 2 ports available for that BT power. But obviously, if you have a device that requires that 60 watts of power, since you have a PoE budget of 60 watts, you can only power up that one device. But depending on the actual power consumption of the device, it depends if you can power up 1 or 2. Okay, then we go into the features that we have. First, starting off with the extended range, which was available in both the managed and the unmanaged series. So why do we need an extended range PoE? Well, because we need longer cables in some cases. So if we would do this with a standard Ethernet switches, we have a maximum cable length of 100 meters when dealing with Ethernet. So if we have a 350 meters distance we need to cover between the office and the parking lot, we need to have 2 additional active devices to split the distance between the office and the parking lot, so we can actually get the signal to the cameras there. So we would need 2 additional switches, more cabling, we would need some sort of cabinets to install these switches, etc., etc. So more hardware, more work. So why not doing it with an extended PoE? So we can extend the cable length up to 250 meters. And by doing this, we need to make some adjustments. First of all, since the cable length is longer, there is much more attenuation in the cable. So even though the switch is being forced to AT standard, or 30 watts, or actually 33 watts in this case, it can only supply power to an AF standard device in the other end, meaning maximum of 15.4 watts. And this is due to the attenuation of the voltage in the cabling. And of course, we also need to drop the link speed from 1 gigabit to 10 megabits. But that is sufficient for most HD quality videos. Okay, so key points with extended PoE. So power device always should be AF, so it cannot consume more than 12.95 watts of PoE power. It has to be capable of 10 megabits of link speed, either auto-negotiate or manually adjusted. And of course, it would be best if it supports the extended range PoE. Then it can automatically negotiate these factors. And then the switch needs to support AT standard mode as first, due to the fact that there is much more attenuation in the cabling, and it needs to apply to a fixed link speed of 10 megabytes. And the Ethernet cable between the PD and the PSC needs to be at least Cat5e or Cat6 or Cat7. So how do we set it up then? So on the unmanaged switches, since we do not have any software management like the Web GUI, we have DIP switches to play around with. And on the front panel, it always says that when the DIP switches are in which position, you power up either ports 1, 1, 2, 1 to 3, and or 1 to 4, depending on the position of the DIP switches. And on the two bigger models, we support up to 4 ports in the extended PoE mode, and on the smaller one, up to 2 ports in the extended PoE. And we always do recommend that first do the settings on the switch and then plug in your cables, just to verify that the negotiation between the switch and the power device or the camera is correct and valid. And from the link LEDs, you are able to verify that this actually happens. So you can see that the link speed is amber, so 10 megabits per second, and the PoE shows green, that the switch is sending AT standard power. On the managed switches, we do this from the web interface or from the CLI, but since it is far more easier in the web interface, it's what we are showing here. So we basically just tick a box, extended range on a certain port, and then we click apply. And then, since we are talking about switches, we always need to remember to save the configuration. If we do not, when the switch reboots next, the configuration is gone. This is standard for all switch manufacturers. You can also see the same results from the LEDs on the port. So link speed amber for 10 megabits and PoE LED green for AT standard. So issues that we have with, or obstacles that we have with extended range PoE is that not all devices actually support it up to standard. And also, since cable length and cable attenuation becomes very important, if there are low quality cables or if there are damaged cables on any way, the range might suffer. So we have, in our internal testing, have found out that, for example, cameras that are fitted with such pigtail connectors, as shown in the picture, attenuate the signal for quite a lot. So you might not be able to reach the full 250 meters with cameras that have these types of fittings. And also some cameras haven't been working with Cat5e cables up to those 250 meters, but they have worked fine when testing with a shielded Cat6 or a Cat7 cable. So just something to be aware of. Okay, so when the tips of extended range, they are fairly simple. So if you have the possibility, test the cable before the actual installation. There are 2 tests you should take. First of all, if the camera powers up or not. And the second, is it able to do the data transmission? So ping the camera. Does the camera respond to ping? And is the response good or not? There are quite few things you can actually do to improve this. One, better brand of cable, better shielding of the cable, or better category cable. So if you have a Cat5e cable, you might go to Cat6 or Cat7 cable and get that working that way. Well, shorten cable length, usually a bit difficult to do because the camera is in a fixed position and the switch is in a fixed position. So in some cases maybe, but usually quite difficult to do, to find a better cabling route or a shorter cabling route. But those are the things you can do. Okay, so continuous PoE explained. So this software feature on the 1350s is designed to keep your cameras alive at all times. So basically, in summary, if you have the power cable plugged into the switch, it is able to keep those cameras up and running. During a switch soft reboot, reloading a configuration file, resetting the factory default, firmware upgrades, or if the switch reboots to a fault status of some sort, it is able to keep the cameras alive. The reason for this feature is basically to reduce downtime. So even though the switch reboots, it's unable to transmit data for a short period of time. But in normal circumstances, without this feature, it would cut the power from the cameras, meaning that after the switch reboots, it would have to boot up the cameras as well, meaning that you would have double the amount of downtime because the switch needs to reboot and the cameras need to reboot. So by doing continuous PoE, we can reduce that downtime to only the switch rebooting. So the cameras are already alive when the switch comes up, so they are already ready to transmit. So setting up the feature is very simple. It is a common feature for whole of switch. You just tick continuous PoE active from the PoE setup, where you also set the classification and the classification or the consumption mode. Then the other thing you need to do is have the PD on at the port. So the port needs to supply power, simple as that. When having continuous PoE on, when you are doing some sort of software changes that require a reboot, the message changes. So if you have it enabled, it will tell you that the devices will be kept powered. If you have the continuous PoE disabled, it will say that the PDs will be power cycled. So just to notice that also the messaging from the switch changes, so you can clearly see if it's on or off when you do a reboot. Okay, so then we go into the best feature of them all, so auto camera recovery and how it works in the background. So a part of auto camera recovery comes a camera status screen. So you are able to name the ports as we shown on the slide, for example, east hallway and entrance, so you can see where the camera is located. You can see the PD health with a standard traffic light system. So of course, green, good, yellow, pending, and red, bad. Link speeds, power draws, so how much power does the device actually take from the switch? What is the system name? What's its IP address? You can even power cycle the port from this screen. Then we have two options available on the PD auto camera recovery, and you can also set the values that we are going to talk about next. So you set the auto camera recovery active on each port you want it active. With an LLDP, it automatically takes the LLDP packets from the camera, meaning the neighboring packets, and acts accordingly. And then you select either reboot or reboot an alarm, or reboot, which is the action it takes if the camera drops down. And then you are able to set the polling intervals, etc. from this screen as well. Or in a ping mode, you need to enter the IP address of the device and set the polling interval and polling count there as well. So a bit more details on what is the difference between these two modes. So in a ping mode, switch sends a ping request to the camera. Are you alive? Works for all networking devices regardless of brand, manufacturer, standard. All networking devices respond to ping, or at least they should. LLDP is a commonly used neighboring protocol of networking devices, meaning that it's able to supply more information. My IP address is this, my MAC address is this, my device name is this, etc. So as we saw on the previous screen about the Axis cameras, that information is supplied by LLDP. So by standard, and all of these timers, etc. are adjustable from the web GUI, but as standard, it works as this way. So by default, LLDP packets are sent from the switch and from the camera in intervals of 30 seconds. And then the switch will set this device or this camera to its LLDP table. And it waits 600 seconds between checks to this table. So if I have a device added to my LLDP table and 600 seconds afterwards, it's not there. So I know that the device has gone from this port, meaning that it's most likely failed. So then we go into recovery action. So resume power interval value in the previous slide or in the configuration page. So how long do we keep the port down? So how long is the reboot for that power off time for that device? As standard, it is 10 seconds. So we drop the port for 10 seconds. Then we power it back again after 10 seconds, and then we keep monitoring as normal. Does the device appear back to our LLDP table? Okay, if not, we are able to try up to 10 times to recover that device. In this example, we are just doing it once. And if we just set it to 1, it will reboot an alarm, or however you set it, either just reboot an alarm or just alarm without trying to recover. And then it just keeps monitoring it and checking the LLDP table between 600 seconds and acting according to the specifications that you have set. So from the logging perspective, and we read logs from bottom to up. So all the most recent logging information is on the top. So if we go from the bottom up, we see that a failure has been detected in port 2, and we are going into auto recovery mode in LLDP mode. So we drop the port for 10 seconds, and then we start delivering the power again. And then we detect if that device comes back alive or not, which in this log entry it does not. And we have tried it as many times as we have set, which is 1 in this example. So we will not try again. So the camera will not go into an infinite reboot loop. If it's not being recovered in a couple of tries, probably there is something other wrong with it that can't be resolved by just rebooting the switch, but somebody needs to get on site to actually, rebooting the camera. Somebody has to get on site to investigate. Ping mode is fairly similar. The difference is the way it tries to or investigates if the device is alive or not. So basically the switch is pinging the device in intervals of 20 seconds, and this is adjustable as well. So it pings the device in between the 20 seconds. It does this cycle 3 times and always 9 pings per cycle. So it has to make sure that you just do not lose 1 or 2 pings here and there for it to reboot the device, because especially with longer cables, you might see ping loss, you might see lost packets. And if it would take every false positive that it gets from the line, the cameras would be rebooted very, very often. So it has to make sure that it loses all of these 9 pings 3 times in a row for it to actually take action. So it has to make sure that the device is actually unresponsive at the other end. So then we go into the resume power interval. So the device will be powered off for 10 seconds and powered back on after 10 seconds. And doing this as many times, once again, you have set from the web GUI, and then resuming the monitoring for between 600 seconds intervals as normal. And yeah, very similar functions. From the locking perspective, more or less same. It just says ping mode. So it was able to determine the issue by doing the ping check has failed, yada yada yada, rebooting or power cycling the port. And once again, this example is from that the device has not started to respond after this action has been taken. So how do you set it up is enabling the feature from the top of the page and then selecting which ports are active and which ports are not, and then selecting the mode LLDP or ping. LLDP recognizes the device automatically if the device supports LLDP. If the device does not support LLDP, recommended to use ping, but then you manually need to set the IP address of that device that it pings. You can set the polling intervals as shown on the previous slides. How many times does it try to poll do the ping check, and does it only reboot? Does it only alarm or reboot an alarm? It sends the alarm via an SNMP trap. Then you can set the polling intervals, the BT report count, so how many times do I try to recover the device, and the resume power interval, so how long of a time is the port down before powering it up again. And it's important to set it at least to 10 seconds in my opinion, because it's never good to just do a quick power surge of drawing out the power and powering it back in, because then the switch or the PD the condensers, etc., will still remain, have some power in them. Okay. Then more detail on the traffic lights, how they work. Of course, green is good, so then we know that the device is up, live and responding. Orange or yellow is that the device is in a middle of power recycling, so a switch is trying to recover this device. And red is that this device is no longer responsive, even though we have tried to recover it the way specified in the settings. So fairly simple. Then a summary of the new devices, the unmanaged and the managed series, all of their PoE budgets, and something worth of noting that even the unmanaged switches have a higher PoE budget than the 1100 or the 1900 series switches. They all have an internal power supply, and they have a max power LAD, so you are able to see when you are reaching on the top end of your PoE budget. They all also support the extended range PoE and minus 20 degrees to 50 degrees of operating temperature. On the managed switches, you have all of these features, and on top of them, the power LADs are a bit different. So you have an indicator LAD in between 20%. So you are able to see the amount of PoE budget consumed from the front panel fairly easily. So you can see how much you still have remaining. Then you have a restore button, which enables you to set your own custom default configuration to the switch. So it's basically a misconfiguration prevention. So if you happen to do some mistakes when you are doing remote configurations and you lose your connectivity to that switch, before you would only have the option to reset it to factory default and start from the beginning. And that would obviously mean that you need to drive on location, or you need to have somebody with a remote desktop on that location so you can gain access to that switch once again. So that allows you to set your own custom default configuration where you have your fixed managed IP addresses, you have all your interfaces set as it would be in your setup. So somebody on site that can just push a button and you can gain access to that switch again. So very handy feature, especially on remote locations. Okay, so and this was more or less what I was trying to say today. Hopefully some of it catched on. Now we will have a Q&A, and we have some questions already. And on the screen you can see the promotions that we have in Q4 while you are waiting for answers. Question number 1, the CCTV switches, are they allocated mode or consumption mode? So unmanaged switches are always in consumption mode. With the managed switches, you are able to select either consumption or classification mode. Does the switches come with consumption mode activated by default? Yes. You also see LED lamps. Oh, yeah. Yeah, that's another question. You also see LED lamps powered by PoE. They just called it something else. That's a very good question. But even though it might be a non-standard PoE, as described earlier, you are able to set the values manually to that port. If it's unable to negotiate the PoE classification with the device, you can set it manually. So you can basically power up any PoE device with that, no matter what it's called. If it takes power from Ethernet, you could power it up. Why did only the 1315 6HP have BT standard? Why didn't the models with more ports have that available? The reason is manufacturing pricing. So BT powered ports are quite expensive. So the 6HP is meant to compete with PoE injectors, and it's similarly priced as a common BT standard or a classification injector. So you can get a lot more device for your money by using that switch instead of an injector. And the reason why it's not on the bigger models, because the pricing of the bigger models would go up quite drastically, and the BT devices would take up a big chunk of PoE power from the switches PoE budget. Are switches including rack mounts? Yes, all except the 6HP. And then the other question, are all switches 19-inch mountable? Yes, with the exception of the 6HP. Okay, so that was all the questions so far. I will keep the webinar running for a couple of minutes if there are any more questions. If not, I would like to thank you all for attending, and hopefully this was helpful for you. Hopefully you catched on something new. Obviously, if you want to try these switches in your own environment, we are happy to give you an NFR pricing. So just please contact a sales person at your region to get an NFR pricing so you can test it out yourself. And if there are any more questions that come to your mind after this webinar, just drop me an email to jukka@zyxel.fi. Okay, so thank you once again, and have a really great afternoon. It is very gray in Finland, so at least I hope the weather is better in the other parts of the Nordic. Anyway, keeping the webinar running for a few minutes if there are any more questions. Thank you all. Okay, only one question from Jacob about the presentation, and I will contact you after this presentation to send you the material. So thank you all once again, whomever is still there, and have a great afternoon. I'll close down the webinar now. Bye-bye.